Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of strings and array, that is the push domino. So before moving on to the question, if you guys are new to our YouTube channel, please do consider subscribing to our YouTube channel. So let's move on to the whiteboard. There I have already placed the question. Okay, so this is our question, that is a push domino. Now there are n domino in a line and we place each domino vertically upright. So what is written, what is actually said in this question is that there are n dominoes that is placed in an array, and it is assumed that all of the dominoes are actually straight upright and they are standing upright, okay, vertically upright. Now what happened that in the beginning some of the dominoes are simultaneously placed either to the left and the right, and that means the some dominoes start falling to the left and some dominoes start falling to the right. Okay, so when a domino start falling to the left, it disturbed its left element. Okay, so let's try to understand it with an example or with the reference. When this domino, as you can see, this domino start falling towards the left. When this domino start falling towards the left, it disturbed its left neighbor, and whenever this domino start falling towards the right, it disturbed its right domino. So this is the approach. This is the question. Now before moving forward, let's try to understand that what is the input format in this question. So in this question, when our domino is straight upright, it is not falling either to the left and the right, it is shown by the dot. Okay, a single dot, it is shown by a single dot. But when a domino is start falling towards the left, it is actually shown towards the shown with the L alphabet, and this L signifies that a domino is pushing or falling towards the left. Similarly, when a domino is falling towards the right, it is shown with the R variable, and this R signifies that the domino is falling towards the right. So that's why the first domino is with the dot, just because it is at the very initial. Okay, at the very initial it is not falling to the anywhere, but the second domino is shown with the L variable. The third is with the dot, just because it is not falling with, to the any side. The other two are shown with the dot. Actually other three. Now again the L, then R, then dot, L, dot. Okay, so this is our input format. Okay, we are given a string of the characters, and this string of the character contains the data like this, and within that data the dot signifies that the domino is straight upright, vertically upright, and it is standing, and the domino at a particular position, if L is written, it shows that that particular domino is actually falling towards the left, and the domino the position where R is written, it shows that that domino is actually falling towards the right. So this is your input format. Now let's try to understand what is actually what are the different cases actually happen when some dominoes start falling towards the left and some start falling towards the right. Okay, so what happened that when some domino start falling towards the left, it actually disturbed its left element, and when it disturbed its left element, there may be a case that that along with the current domino, its neighbor domino also starts falling towards the left. So let's try to understand this case. You can see here this domino, this domino is falling toward the left, and when it starts falling toward the left, it disturbed its left element, and along with this domino, its left neighbor also start falling toward the left, and they fall like this. Okay, they fall like this. Similarly, there may be a case that there is a domino which start falling toward the right, and its neighbor domino is actually standing upright. But when a current domino start falling towards the right and it disturb its neighbor, what the neighbor does, it also start falling toward the right. So the case will be like this. Here you can see that this domino is falling towards the right, and its neighbor is doing nothing. It is actually standing up all right. But when this start falling toward the right, the external force, the right force, actually forces this neighbor to fall towards the right, to go with the flow and to fall toward the right. So both of the neighbors start falling towards the right. Okay, so these are the two cases. Now let's discuss the other two cases. Okay, the other two cases, that is when the left domino when one of the dominoes start start falling towards the left and one of the dominoes start falling towards the right. Here you can see that I'm discussing these two things. Okay, here you can see that this domino is actually falling towards the right and this domino is actually falling towards the left. When both of the dominoes start falling towards the left, there may be cases that the domino which lies in between actually experiences an equal and opposite direction of forces from both the direction. Here you can see that this domino actually experiences a domino and left force from the two dominoes, and here at the same time it experiences right force from the two dominoes. And as there is an equal force of two domino from the left and equal force of two domino from the right, but both are in the opposite direction. So what happened, that the net resultant force it experiences, it will be zero. And as the net resultant force will be zero, so it will not start falling either towards the left and the right, and it keeps standing. Okay, it keeps standing. It will not fall either to the left or either to the right. But there may be cases that when there will be no resultant force actually experienced to one of the domino, and means when the number of domino are even, there will be no domino which nullify, on which this force get nullified. Okay, there will be no domino. So you can see this case. Let me remove the remaining others. You can see this case and this case and this case. Here you can see that the leftmost dominoes start falling towards the right and the rightmost dominoes start falling towards the left, and the moment they start falling over each other, what happened, they disturb their neighbor. But there is no domino between both of these dominoes, falling dominoes. There is no domino on which the resultant force will be nullified. That's why it disturbed their neighbors, but the resultant force will not be nullified. Okay, so you can see that here are the four cases, that one of the dominoes start falling toward the right, it disturbed its left domino. One of the dominoes start falling toward the right, it disturbed its right domino. Some dominoes fall towards the left and the right, but they don't disturb anyone. But some domino, when they start falling, they disturb their neighbors. Okay, they disturb their neighbors, and in some cases the resultant will be nullified. Okay, the net resultant force will be nullified. And even after all this disruption of from the left and the right domino of the falling, means the falling of the left and the right domino, there may be cases that some domino do not encounter any of the forces from any of the domino. So this is our question, and it's my request that you try to read all these things. Okay, this is the question, because when you start reading the questions, the intuition of the question, the ideas about the question start getting into your mind, and this is very good when you start doing the problem solving. Okay, so it's my request, you please read this question by yourself, even though you get the question. Okay, it's my request, please. And along with the reading of this question, please pause this video right now and at least try to solve this question by yourself. So I have assumed that you have tried this question by yourself. So now let's move on to the solution approach, and let's try to discuss that how we will solve this question. Okay, now the first thing which we need to discuss is the output, like how our output will look like. Okay, how the output will look like. So here you can see that this domino, the domino which on which my cursor is on, so this domino is will fall towards the left, and when this domino fall towards the left, it made its left domino to fall towards its left. So as it disturbed its left domino, what happened, that both of the dominoes start falling towards the left. Okay, so means earlier this domino was standing, but it get disturbed by its neighbor, and as the moment it get disturbed, it update its state, that is from the standing state towards the left state. Okay, similarly this domino keeps on standing here, means either it has not experienced any of the force from any of the neighbor, or either the net resultant force on that neighbor on that domino is zero. So what happened, that if in an output some domino will not encounter any of the force, or is it still keep standing, then what we do, we just show it with the dot. Now you can see that this domino is actually falling towards the right, and it was given in the input. So as this input it was falling towards the right, we showing it by the R. But as it start falling but as it start falling, it disturbed its right neighbor and it made them fall towards the right. So its right neighbor changes its state from standing to the right falling. And similarly here also, these two, this leftmost rightmost domino start falling toward the left and it changes the state of the left domino. And but this domino that is lies in between among all these falling dominoes, the net resultant force on this domino is constant. Okay, the net resultant force get nullified. As the force get nullified, what happened with the domino is that it will not experience any force and it is still standing. Okay, it don't experience any force and it is still standing. And as it is standing, we just show it, or we just show it with the dot. Here also, these two start falling toward the left, these two are falling toward the right, these two are falling towards the right, and these two are falling towards the left. But there is no such domino between both of the between all the falling dominoes on which the net resultant force becomes 0. And as there is no domino, so that means there is no standing domino. And these two dominoes are shown by the dot just because it has not experienced any of the force. So this is our output format. Now you might be thinking that how do we approach to this question, how do we solve this question? Okay, so just before moving on to the approach or solving of this question, okay, I'm just saying that we are going to use the dummy domino. By the dummy domino, okay, let's first try to understand the dummy concept. Okay, so in the linked list we use the dummy nodes. What is the significance of this dummy node? That significance was that it does not actually manipulates or changes the actual input, but it helps us to achieve the output. Similarly here we use the concept of dummy domino. But we use how we use it, we just use those dummy dominoes in such a way that it will not manipulate or it will not affect our input, but it will help us to achieve our output. So what I'll do, I'll just assume that there are two dummy dominoes. One dummy dominoes lies here and one dummy dominoes lies at this rightmost point. And as these dominoes were falling either to the left and the right, so that means this domino also need to be fall. So I'm assuming that the leftmost domino is actually falling towards the left and the rightmost domino is actually falling towards the right. So what actually they are doing? They are actually doing nothing new, just because leftmost is falling towards the left and rightmost is falling towards the right. They are not actually affecting our inputs. But what it helps, but how it is helping is that it is helping us in creating a sections. Okay, it is helping us to create the sections in which we will work right now. So okay, let me write the input here at first. So I'm assuming it was dot left dot right, left dot left right dot 3 dots, two dots, left 2 dots. It is an input which we are provided with. Okay, now the output with which we are provided with. Now let's try to solve this question. So to solve this question, I need to use two dummy dominoes, and just to use these two dummy dominoes, what I'll do, I will place a dummy domino on the leftmost extreme point and rightmost extreme point. What these dummy dominoes do actually, the leftmost dummy domino actually falls toward the left and the rightmost dummy domino fall toward the right. Okay, so my input will look like this. My input will now look like this. Now how will I solve this question? Okay, you might be thinking that how will I solve this question? So to solve this question, I'm not going to take the whole input at the same time or start working on it. What I'm going to do is that I'm going to take a section of that and now I will work on that section. So you might be thinking that what section on which I will work. Okay, so you can see that here the one domino is falling towards the left and the other domino is also falling towards the left, and there is a domino which lies in between. Okay, so I can say that when two dominoes, any of the two dominoes, when start performing any of the functionality, either it start falling toward the left, it start falling toward the right, it start falling toward the left, right, or actually performing any of the activity, its neighbors get actually disturbed. Okay, actually its neighbor get disturbed. When any of the two dominoes start performing any of the activity, its neighbor get disturbed. So here you can see that when this domino performs some activity, this domino performs some activity, its neighbor, the neighbor which lies between these dominoes, actually get disturbed. Okay, so what I'll do, I'll just take this section of those domino. I'll take the sections I'll just take the sections in which the extreme points, I'll just extract out the sections in which the extreme points have the dominoes which actually performing some work, and based on their performance, based on the work what they are doing, I will try to predict out the behavior or the disturbance which the dominoes which lies in between actually faces. Okay, so let's try to understand what I'm saying. What I'm going to do is that I'm just going to at first start working on this section, just because here you can see that this become my one of the sections, and here in the extreme, that is the left extreme and the right extreme, that is this and this domino is actually performing some work. What work they are performing? They're either falling toward the left, either falling toward the right. They are actually doing something, and the moment they start doing their work, the neighbor, the domino that lies between both of these extreme dominoes, they actually get disturbed. And what I need to do in this question is that I just need to find out that what will be the behavior of that domino after the disturbance. Okay, so what I'll do, I'll just at first take this section and start working on it. The moment I'll finish it work, what I'll do, I'll just take this section now. Why? Just because I worked on that neighbor which were earlier standing and their neighbors were performing some work. Now I'm going to do choose the another section in which now new dominoes will perform some work and their neighbors get disturbed. Similarly, after this I'll take this section, and my faith will remain same, that the extreme dominoes are actually performing something and disturbing the dominoes which lies in between. Okay, and the moment they start disturbing their dominoes, the middle dominoes, their behavior changes. The dominoes that lies in between, their behavior changes, and I just need to map out that what behavior they will accept after that. Okay, now let's try to understand that what are the cases which we encounter when we start dealing with the dominoes. Okay, so the first case is that, like, I'm always here, definitely I am only encounter the cases of the left and the right domino, just because I know when I choose a section, the behavior of the internal dominoes that lies in the middle are actually get affected by the dominoes which lies at the extreme position. So what is my faith is that I'll just try to figure out what are the behavior of the extremmost dominoes. On the behavior of the extremmost dominoes, I try to predict what the behavior the middle dominoes adapt. So if the extremmost left domino start falling toward the left, and the extremmost right domino start falling toward the right, falling toward the left, that is this case. That is this case. Here you can see I have assumed that there is a domino. And you can see this is a section. So when the within this section, when the extremmost left domino start falling toward the left and the extremmost right domino start falling toward the left, what happens to its domino that lies in between is that these dominoes also start falling toward the left. Towards left. Okay, you can see that why they are falling towards the left, just because they go with the flow of their neighbors. Okay, these dominoes go with the flow with their neighbors. Now similarly the second case, that is, if the leftmost domino of a section and the rightmost domino of a section, both of those dominoes actually start falling toward the right. Means if this domino start falling toward the right and if this domino start falling toward the right, what happened to all the dominoes which lies in between both of the dominoes are that they actually start falling toward the left. They actually start falling towards right. This time they actually start falling toward the right. Why are they falling toward the right? Just because they go with the flow of their neighbors. Okay, the neighbors are falling toward the right, so they go with the right. Okay, now the other points. That is, if the if the leftmost domino start falling towards the left and the rightmost domino of a section start falling toward the right, if the leftmost domino start falling toward left and the rightmost domino start falling towards right, what happened to all the dominoes which lies in between is that they don't even experience any of the force on them. Why? Here you can see that these domino, okay, these dominoes are actually falling toward the left and these dominoes are actually falling toward the right. So this domino that is the earlier standing are still remains standing. Why? Just because it will not experience any of the force from the neighbors. So no work. Okay, or I can say still standing. Okay, there is one more case, that is if the leftmost domino start falling towards the right and the rightmost domino start falling towards the left. The moment such a case arises, when the leftmost domino start falling towards the right and the rightmost domino start falling towards the left, what happened? There are two cases arise. There is a one case. Okay. Here I am writing that I need to do some work. What will be work? What the work we will do, I just figure out soon. But here I'm writing that I need to do some work. Okay, so before discussing this case, before solving this case, let me again revise it. That if both of the, like I have extracted out a section and now I am working on a section, and based on the extremmost dominoes of that section, I'll just try to figure out what will the behavior of the nodes which lies in between. So what will happen is that the dominoes, okay, so the dominoes, when both of the extremmost position dominoes are actually falling toward the left, the domino which lies in between also falling toward the left. When both of the extremmost dominoes are actually falling toward the right, the domino in the between also falling toward the right. When the left domino start falling toward the left, the extremmost left start falling toward the left and the extremmost right falling toward the right, which happened to the middle is that they still remain standing. Why? Just because it will not experience any of the force. Okay, it is not experiencing any of the force. Okay, now the fourth domino, when the leftmost domino start falling toward the right and the leftmost domino, when the leftmost domino start falling toward the right and the rightmost domino start falling toward the left, when these domino when these dominoes start falling towards the center, what happen? There are two cases arise. Okay, let's try to figure out what will be those cases. Two cases arise. So the first case is if the number of dominoes that lies between both of the extremmost dominoes, the number of dominoes between both of, excluding those dominoes, are, if those number of dominoes are odd. If those number of dominoes are odd, what happened? That except the middle section, all the dominoes lying on the left start falling toward the left, but all the dominoes lying towards the right start falling toward the right. But the domino which lies at the middle position, what happened with that is that it experiences zero force. Why? Because it is actually experiencing an equal and opposite force, and the moment it experience an equal and the opposite force, what happen? Its force get nullified. Okay, that's why it is experiencing zero force. Means here this domino, when these dominoes start falling toward the left, these dominoes start falling toward the right, what happen? You can see here is the odd number of dominoes. So this middle one domino, that is the domino which lies in the middle position, what happened? All the dominoes its left start falling left and all the dominoes its right start falling right, but this domino still keeps standing. Why? Just because the net force on it is zero. It is not encountering any of the force, or I can say that the net balance force on it is zero. But this is the case of odd number of nodes. Then we case that when there is even number of nodes. Okay, in this section what is happening? That these nodes start falling towards the center, these nodes start falling towards the center. But you can see there are even number of nodes which are lying between the extrememost points. Okay, between this section. Okay, excluding the rightmost and the leftmost domino. So here you can see, as there are even number of dominoes, what happen, there is no such a node, there is no such a domino on which the net balance force will become 0. So what happened, half number of dominoes start falling towards the left, half number of dominoes start falling towards the right, and as there is no such domino on which the net experience force is 0, and there is no such domino which keeps standing at the last. So let me write it. Let me write it here, that here work will be done on the basis of condition. Okay, on the basis of condition, there are two conditions. First condition is if n is odd, means the number of dominoes which lies between both of the excluding the extreme most dominoes is odd. If those number of dominoes is odd, then the middle one domino keeps standing. One will keep standing. Okay, and all the other dominoes which lies on the left and the right start falling by following the path of their neighbors. Okay, they start falling towards the center by following the path of the neighbor. But if it is even, all the dominoes start falling. Actually, in this case, all dominoes start falling. There will be no domino which will be keep standing here. All dominoes start falling. I hope you get the intuition of this question, that how we will solve or approach to this question. Here we are just doing nothing, we are just handling the cases which the dominoes actually experience. Okay, and one more thing which we are doing in this question is that I am here adding a two dummy domino, one at the very left extreme and one at the very right extreme. Or what these dominoes actually doing, they are not actually manipulating the input, they are actually helping me to achieve the output. Okay, so how it is achieving, it helps me to create a sections, and after creating a section I start working on a section by a faith. Okay, I'm working on a section by a faith that all the dominoes which lies in that section. Okay, all those dominoes which actually lies in this section are actually and are currently standing. Their nature or the motion which they follow will actually determined by the dominoes of their neighbor. Okay, so that's all. Now that's for the explanation part. Now what we are going to do is that we're going to move on to the Pepcoding portal, and there we write the code of it. So this is a Pepcoding portal, and now what we are going to do is that we just need to complete this push dominoes function. Okay, so at first I'm going to write the code, and the moment I will complete my code, I will start explaining you. Okay, after it I will explain you. So the first thing I'm going to do is I'm going to create a vector. What is the significance of this vector? Soon I will explain you. Okay, so str.length plus 2. Now array 0 will be the L, and array arr.size minus 1 will be the R. Okay, so array 0, array size minus 1, R. Now I will run a loop for int I equals to 1 is less than equals to, not less than equals to, I is less than arr.size minus 1 and I plus plus, and I'll update the positions here. Array I will be nothing but str at I minus 1. So let me explain you what I have done till now. I have already explained you during the explanation part that just to solve this question, just to get the output of this question, we use two dummy domino. So I have created an array of the size greater than the 2. Okay, and at the very initial size on the very left hand side and on the very right hand side I have put that dominoes. Okay, now let me write some more code, that is j equals to 0 and int k equals to 1. Okay, and j equals to 0 and k equals to 1 while k is less than arr.size similar size, and also while arrk is not okay, ARR k is equals to dot. What I'll do in this case, I'll just keep on counting the incrementing the k plus plus. Okay, now if k is greater than j, k minus j is greater than 1, k minus j is greater than 1. If this is the case, I will call some function that is solve configuration function. Solve configuration function, and this function will perform something, array I j. Okay, what is the significance of this function? Soon I will explain you. Okay, at last I will update the j with a k and increment k plus plus. So let me explain you what I have done. I have coded till now. So now I have already told you that in this question we'll solve this question by working on a section, on each section. So what is the significance of this first while loop is that using this first while loop we will iterate over the whole array, and using this second while loop what we will do, we just fetch out a section, and here we are just calling that solve configuration function. What we are doing is that we are just passing that section to a solve configuration function, and this solve configuration function update our array. So let me write the code of this solve configuration function. So here I will write void solve configuration function, and vector of char reference array. Okay, here there are some mistakes. Vector of char reference array int I int j. Now we already know that the moment we start working on a section, there are 4 conditions which we encounter, and those 4 conditions are nothing but the extreme, means both of the extreme points are laying towards the left or laying towards the right, and they are either falling towards left and right, and they are start falling towards the center. So we need to handle both of all the conditions. So if ARR, array of I, start falling towards the left, and array of j starts falling towards the left. If both of them falling towards the left, I will do some work. What I'll do, for int k equals to I plus 1, and k is less than j, and k plus plus, means all those dominoes which lies between both of the extreme points start falling towards the left. They are just doing nothing, they are just following the path of their neighbors. Okay, so array k start falling towards the left, they get updated with the L. Otherwise there is one more if condition, so let me copy it. It is the else if, okay, else control v. Okay, so array I and array j means both of the extreme points lying towards the right hand side, means when both the extreme points lying toward the start falling towards the right hand side, the dominoes which lies between both of the extreme points, they also start following their neighbors and start falling towards the right hand side. So here also I'll update, but this time with the right side. Now this is a different case, that is if array I start falling towards the left hand side and array j in this case start falling towards the right hand side. If this is the case, then I don't need to do nothing. Why? Just because both of the extreme points are actually here I was writing the code else, because in this case both of the extreme points are actually doing nothing. They are not even actually affecting or actually disturbing their neighbors. Okay, means the dominoes which lies between both of the extreme points, they get undisturbed. That's why here we do nothing. But in the last case, when both of the left and the right dominoes start falling towards the center, okay, in this we have already discussed that 2 cases arise. What are the 2 cases? The 2 cases arise when the dominoes that lies between this section, excluding the extreme dominoes, okay, that is the critical points, excluding those critical points, if the domino count is even, that means there is no point on which the net external force becomes 0, and if there is an odd number of dominoes, there is a point on which the net external force becomes 0. So I'll check if, okay, at first I will calculate the difference j minus I. Okay, after that I will check if that difference modulus 2 is even, means in this case there is no balancing point means there is no domino on which the net balance force becomes 0, otherwise there is a point on which the balance net force becomes 0. Now let me calculate the mid will become I plus j, I plus j modulus 2, okay, and for int k equals to I plus 1, k is less than mid, and k plus plus. Similarly, for int k equals to mid plus 1, k is less than j, and k plus plus, okay. So in this case my array at k get updated with the right, and in this case array at k get updated with the left, okay. The same type of thing I'll do in the else part, okay. So let me copy it and let me put it here, so int I plus j, but this time my loop will run till less than equals to the mid, okay. So less than equals to mid, k plus plus, array I right, otherwise mid plus 1, k is less than j, array I left. Now one more thing which I need to do here in the push Dominoes function is that converting our answer into the string. So what I need to do is that I just need to create a new variable, string res. I need to run a loop for int I equals to 1 to I is less than array dot size minus 1 and k plus plus, actually I plus plus, okay. So res plus equals to array at I and return res. So that's all for the code. Now what we are going to do is that we are just going to run it for all the test cases, and if you encounter any error we just try to figure it out, okay. So here we are running it and we get some error, that is void configuration vector reference array, vector char reference array int I, okay. There need to be some space between them, and also int kl, okay. I forgot to put the semicolon here. These are the small mistakes, okay. One more here, also I forgot to put the semicolon, okay. So configuration array ij, okay. The problem is the name of the function. I just configure GURATI1. So now again let's check, okay. Still the name of the function is wrong. Let me copy it from here, okay. Copy it from here, and yeah, and let me put it here. Most probably this time it will work. So all configuration, okay. The error we are getting right now is we have not declared the I and j, so the actual variables are j and k. This was our mistake, and yeah, it is accepted. Let's try to submit it for all the test cases, and most probably it will work. So the last thing which I just, yeah, it is accepted for all the test cases. The last thing which I just want to tell you is that please please thoroughly read the problem statement, because if you read the problem statement thoroughly, it will help you to get the intuition of this question. It will help you to get the deep insights of the question, and also if you get the concept of this question, then please try to run it by yourself, okay. So that's all for this video. Let's meet in the next video. Till then, stay safe, stay healthy.